Alright, hello everyone. Welcome to today's class, which will be on sum and product of the roots of a quadratic equation. So, first of all, let's look at the general form of a quadratic equation. The general form of a quadratic equation is ax squared plus bx plus c equals to 0. So, the roots of a quadratic equation are the solution you get when solving a quadratic equation. Of course, when you solve a quadratic equation, you have x equal to, for instance, x equal to 1 or minus 3. We'll say that 1 and minus 3 are the roots of the quadratic equation. So to derive the sum and product of roots, let's use a given item and name it to be the root. Let's say that let x be equal to alpha and x be equal to beta. Let x and alpha be the root of the quadratic equation. So if x is the root of a quadratic equation, it means x will be equal to alpha. If alpha is the root, x is equal to alpha, and if beta is the root, x will be equal to beta. So to form a quadratic equation, we now have x minus alpha, which is equal to 0, multiplied by x minus beta, which is equal to 0. So if x is equal to alpha, it therefore means that x minus alpha equal to 0. And then if x is equal to beta, it therefore means that x minus beta equal to 0. So we'll multiply these two expressions together. So by expanding this, you have x squared minus alpha x, x squared minus alpha x, then minus beta x plus alpha beta equals 0. So what we have here, this will now be x squared. So since x is common here, we can use x to factorize. That is minus x. So inside the bracket, you now be alpha plus beta plus alpha beta equals 0. So you can still rearrange this as x squared minus alpha plus beta x plus alpha beta, which is equal to 0. So if you compare this with the general form of a quadratic equation, you have ax squared plus bx plus c equals 0. You realize that here our x squared has a coefficient of 1. So before we can do a direct comparison, we can make this x squared on general form of a quadratic equation have a coefficient of 1, and by doing so we divide through by a. So let's divide through by a. So you now have this expression as x squared plus b all over a x plus c all over a equals 0. So by direct comparison, let me copy it so that I can draw lines. Minus alpha plus beta x plus alpha beta equals 0. So by direct comparison, we have x squared, then we have minus x plus beta as a quotient of x. So we have minus alpha plus beta will be equal to the quotient of x here will be b all over a. So on doing so, you have alpha plus beta will now be equal to minus b all over a. So this will be the sum of roots. So the sum of roots of the quadratic equation is equal to minus b over a. So let's look at the product. The product here we have alpha times beta, which is equal to takes the portion of c all over a. So alpha beta will be equal to c all over a. So this is termed as the product of roots of a quadratic equation. So negative coefficient of x in a quadratic equation where x square, coefficient of x square is 1, is the sum of roots. And then when the coefficient of x square is 1, the constant stands for the product of roots. Now let's look at an alternative way. Using the general form of a quadratic equation, x equal to minus b plus or minus root b square minus 4ac all divided by 2a. You can see that for you to have a solution of the quadratic equation here, the difference here will be you will use the first answer will go with the plus, the second one go with the minus. But let's not take this bulky b square minus 4ac. Let's say that let d, which is the discriminant, be equal to b square minus 4ac. So we won't be carrying b square minus 4ac, but we'll use d instead so that we can make the equation formula looks simpler. So you have minus b plus or minus root. This now becomes d all over 2a because d is b square minus 4ac. So we're using the discriminant now. So for the root of a quadratic equation, we have two answers. We have x being equal to minus b plus root d all over 2a, or x being equal to minus b minus root d all over 2a. Okay, so from what you have here, these are the roots of the quadratic equation: minus b plus d and minus b minus root d over 2a. So let's look at adding them, which is the sum of roots. So for sum of roots, let's start with the sum of roots. Sum of roots. For sum of roots, what we do is you will add minus b plus root d all over 2a plus minus b minus root d all over 2a. So of course the LCM here is 2a. So since we have a common denominator, we just add the numerators direct. Minus b plus root d minus plus and minus is minus b minus root d. So this will be equal to minus b gives us minus 2b all over plus d minus root d makes it 0. That is, we have minus 2b all over 2a. So 2 and 2 divide. Therefore, the sum of root will be minus b all over a. Alright, so this is the sum of roots, minus b over a. So let's look at the product of roots. So the product of roots product is multiplication. So we are having minus b plus root d all over 2a times minus b minus root d all over 2a. Okay, so from what you have here, this will be equal to, let's expand the numerator, which will have minus b times minus b, which is b square, then minus b times minus root d, that will be plus b root d, then here we have minus b root d, then root d times root d, which is minus d, because root d times root d gives us d, then plus or minus, which is minus. So all divide by 2a times 2a, which is 4a squared. Okay, so this will now be equal to b root d minus b root d is 0. So we're having b squared minus d. And what's our d? Our d is the discriminant. Let's bring back the discriminant, which is b squared minus 4ac all over 4a squared. So from doing so, we expand that and have b squared minus b squared minus times minus, which is plus 4ac all over 4a squared. Okay, so from this you have it to be equal to b squared minus b squared 0. We are left with 4ac all over 4a squared. So a and a divide, 4 and 4 divide, so we are left with c all over a. So of course c all over a is the product of roots of a quadratic equation. Alright, so for now that's it.